Let's take a look at 3.8, Newton's method, on page 264, example 1. Starting with x1 equals 2, find the third approximation, x3, to the root of the equation, x cubed minus 2x minus 5 equals 0. So first, it's nice to recognize this polynomial here, f of x equals x cubed minus 2x minus 5. We're going to start with initial guess. This is given. x1 equals 2. This is the root that we're guessing. So according to Newton's formula, the next guess, the next root, x to the n plus 1, is equal to the previous guess minus f of xn over f prime of xn. Let's see how this works. So because we're using a derivative formula here, it's nice to take the f of x and then figure out the derivative using power rule. So f prime of x is equal to 3x squared minus 2. So this is simply plug and chug using your calculator. And what we have here is we're going to begin by setting n equals 1. So you can see when n is 1, 1 plus 1 becomes 2. So we're just going to substitute n equals 1 here, 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 and here. And we're going to use the formula. So 1 plus 1 is 2, x2 equals 2, that's our x1, which happens to be given as 2, minus f of x. F of x1, x1 happens to be 2, this is just function substitution. What is f of x? F of x up here is going to be something cubed minus 2 times something minus 5, and as you can see we have the right shape here. What is f prime of x? It's going to be 3 something squared minus 2, 3 something squared minus 2, and we're going to substitute in x1 over here. Just use a nice calculator, and the answer is 2.1. So that's it. That's how Newton's method works. We have a better guess, x2, better than the previous guess, based off this formula. Let's keep going to get even closer and closer, and Newton's method gets close very fast to the roots. And it says here, learn how to use store on your calculator. So let's practice this. We're going to store 2.1 on your calculator, 2.1. I'm going to press the STO button, so everyone's calculator is different. Some of you guys might have memory or memory recall and all those kind of buttons. But I'm going to store it into alpha A. So I'm going to store it into the CI84, variable A, enter. So now 2.1 is in variable A, and I'm going to set up the shape here. What I have here is that unknown variable 2, so it's going to be alpha A minus, I'm going to press alpha y equals enter. That's going to be box over box. It's going to be something cubed. It's going to be A exponent cubed minus 2A minus 5 all over. It's going to be 3 times that A value squared minus 2. Okay, press enter, and you can see that we have a better guess. This is 2.09-ish, and you can see that we now have 2.09-ish, and that's great. And we're going to keep on going here. As you can see that when you plug in the 2.09, just to finish out the train of thought, as you plug in 2.09, this by the way is accurate to x3. If you want to go even further, you can just press store alpha A, press enter, and as you can see that this value, this better root, goes into A, and you just press up on your calculator a few times. When you press up, 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 press enter, enter, it automatically gives you even a better value. And as these digits start aligning for the 10th, 100th, 1000th, you can see that we're getting better and better decimal accuracy.